This is a video for my geometry students for the selected solutions from Chapter 7, Section 3. Here's two problems. We've got problem number 3 and problem number 4 in 7-3. The first one is saying, verify that the triangles are similar. So if those two triangles were similar, and we see that we've got the measurements of all three sides, the sides would be proportional. And it's important to note this order that they want us to compare, because that's going to allow us to write this proportional statement, this proportionality statement. DE is to JK as EF is to KL and DF is to JL. So plug in the measures that we have from the triangle, and you've got those. Notice that all of those fractions reduce to 1/2, so that's a true statement. And therefore, since that's a true statement, those three proportions are all equal, the triangles are similar because of side-side-side triangle similarity theorem. You didn't need to write all of this, though, for your problem, because it just says verify that the triangles are similar. All you needed to write were these two things here, the proportions, 8 to 16 equals 10 to 20 equals 6 to 12. Show that that's true, so show that they all reduce to 1/2, and then say, therefore, side-side-side triangle similarity theorem. In problem number 4, we first have to identify that again, we're looking at these triangles that they're talking about here. And we note what are the corresponding parts given that triangle MNP in that order and the triangle MRQ in that order. So I highlighted in green two corresponding parts. And here in orange, I've actually highlighted two corresponding parts. One of them kind of almost overlaps another, but those are corresponding parts that I would be using for the proportionality statement. So I need to show that I have two pair of proportional sides. And I plug in the numbers that we have for those. And I got 4 6 equals 8 twelfths. And notice that both of those reduce to 2/3. So two pairs of corresponding sides are proportional. And the angle that's included between the sides that I was comparing are also congruent, and that shows that in the figure here. It shows that. And so therefore, I know the triangles are similar because of side, angle, side, triangle congruency, triangle similarity theorem. Again, what did you need to write for this problem? You needed to write these three things that I've circled in green. You had to have the proportionality statement. You had to say that the angle that's included is congruent. And therefore you have the side, angle, side, triangle similarity theorem. Problems number 5 and 6. Explain why the triangles are similar and then find each length, the length that's asked for. So in problem number 5, we need to prove this little triangle, triangle AED, and the big triangle, triangle ACB, are similar triangles, and we need to find the measure of the segment AB. And both triangles use this angle A. So that's important. Because of that, I need to say that angle A is in one triangle and angle A is in the other triangle. And so you're going to be using that angle A is congruent to itself by reflexive property. It's given that these angles that I just marked there, I made them darker in red. It's given that those angles are congruent. And therefore, that's two angles in one triangle and two angles in another. The angle A and one of the red angles and angle A and the other red angle in the two different triangles. And so we have angle, angle, triangle similarity theorem. And since the triangles are similar, I take the corresponding parts, and 6 corresponds to AB, as ED, the 9, corresponds to CB, the 15. And then I'm going to solve it, and I can just cross multiply. You could simplify and do it that way, but I'll just do it the way the textbook, with cross multiplying and then dividing by 9. 9 cancels on the right hand side. 9 goes into 6 2 times, well the 3 goes into 6 2 times, and 3 goes into 9 3 times, and then I reduce it even more, and we get that the measure of AB is 10. So that was the answer. In problem number 6, again, we're going to try to prove these triangles are congruent and then find the missing side. Since we have parallel, that was given, I just made it darker so you could see it better. We've got parallel. We therefore, not parallel, we've got alternate interior angles that are congruent. And we also have another pair of alternate interior angles that are congruent. So right now we've got angle, angle, triangle similarity. But just in case you were wondering, we also have the vertical angle, and you could use any pair of angles in one triangle and any that correspond to a pair of angles in the other triangle. Regardless, we've got angle-angle triangle similarity theorem. Now, making sure that you look at corresponding parts. So in that similarity statement, I see that the segment VW corresponds to the segment XW. So 7 corresponds to 8.75. And I can write that. 7 is to 8.75. And now I have to find the other pair of corresponding. And I've got these ones here, that UW and YW, they correspond. And so I'm going to say that 9 is to WY. And cross multiply, and then divide by 7. 7 cancels with 7 on the left, and 7 goes into 8.75, 1.25 times, since I was doing this without a calculator. And then I had to multiply 1.25 times 9, got 11.25, and so WY, the length of the segment WY, is 11.25. And that's the answer to that problem. And these next two problems, they're two proofs. Remember to pause the video at any time if you want to just stop and see where I'm going with it. First of all, I'm marking the given information, that the line MN is parallel to the side KL. And because of that, I've got corresponding angles that are going to be congruent. And I have another pair of corresponding angles that are going to be congruent. So that gets me angle-angle triangle similarity. And that would be the whole proof. So here's statements and reasons. The given information that I just talked about, the fact that those angles are congruent because of corresponding angles postulate, and then the triangles are similar because of angle-angle triangle similarity theorem. And that's the end of the proof. Now let's look at number 8. Again, I'm going to look at that given information, and it's kind of, I can't mark it very easily, but I do know that SQ is the same as twice QP. And therefore, if I look at that side SP, it's going to be made up of those two things. And with the segment addition postulate, I'm going to end up with 3 QPs, because I'll have QP plus the SQ, which is 2 QP. That's a total of 3 QP. And similarly, on the other side, I get that the segment PT is going to be 3 RP, because that was also given information. What wasn't stated but is known from the diagram is that angle P is in both of the triangles. This is similar to one of the previous problems we had, where there's an angle that's in both of the similar triangles. So I'm going to have this reflexive property. And now the two triangles are congruent because I've got two sides and the included angle that are congruent. So here goes the statements. And we have a little bit more because we're going to have to do some adding and stuff. So first of all, the given information. Now I'm going to state the segment addition postulate with just all the little letters for each segment. And then I have the fact that, although I stated in line 2 that SP equals SQ plus QP, I have this substitution I can make. And instead of writing SQ, I'm going to write 2QP. Right? And then for the other equation, TP, I'm going to replace the TR with 2RP. And I have that one. And that's just substitution property of equality. And now, by looking what's on the right-hand sides of both of those equations, I can simplify them, add the parts together, and now if in each of those equations I do some division, you're going to find that the measure of SP over QP equals 3 over 1, so it's 3 to 1, and the measure of TP compared to the measure of RP is also 3 to 1. This is important because this is stated, that statement right there. I don't have to say anything more about it, but I'm highlighting it so you'll recognize that is a statement that's saying sides are proportional, because both of those ratios are equivalent. So we know that's proportionality. Now we're using that angle P is congruent to itself, angle P, because of reflexive, and the triangles are therefore similar because the sides are proportional and the angle included is congruent. So that's the end of that theorem. Hope this helps you with some of your problems that you're doing in this section of geometry.